Hi everyone, my name is Khushraj Malviya and today I'll be presenting on the topic Introduction to Operating Systems, exploring what they are, why we need them and how they work. This will be a fundamental yet insightful journey into the software that silently powers nearly everything we do with computers. So let's get started. Let's begin with the most basic question. What is an operating system? An operating system or OS is the core software that acts as a manager of all the hardware and software on a computer. Think of it as a bridge between physical machine, the CPU, the memory, hard drive, and input and output devices like your keyboard or printer, and the applications we use such as a browser or a word processor. The OS handles complex tasks like memory allocation, process scheduling, and managing files. But it hides these complexities from user and provide a simple interface. Without an OS, a computer is just a collection of electronic components with no way to function. Some popular OS examples include Microsoft Windows, Linux, Mac OS. So let's see why do we need an OS? The answer lies in the role it plays. First, resource management. The OS allocates CPU time, memory space, and disk storage efficiently so that every running application gets what it needs. Second would be multitasking capabilities. It allows you open multiple programs at once, like browsing while listening to music. Third, enhanced security. The OS protects sensitive data and system files from unauthorized access. Then, last but not least, user interface. Finally, it provides the graphical or command and line interface that allows us to interact with the machine easily. So, in short, the OS is what turns the hardware into usable and secure system. Now that we know why we need one, let's dive into how an operating system actually works. At the center is kernel, which which is the brain of the OS. It directly interacts with hardware. Second, system calls. It acts like a middleman. They let application program ask the kernel for services like reading a file. Then process management. It involves the OS tracking and scheduling all the running programs. Then the memory management. As the name suggests, it means allocating the memory to program as needed and reclaiming it back when they finish. File management. It includes organizing files on disk and handling access permissions. Then the last, device management. Device management controls how data works to and from the hardware or devices. So all these six components work together to ensure that everything runs smoothly, often without us even realizing it. There isn't just one type of OS. In fact, operating systems are tailored for different needs. So the first type of OS would be batch OS. It executes similar jobs in batches. Used mainly in older system, it processes jobs in batches without user interaction. The second one is time sharing OS. It is designed so multiple users can share the CPU, common in mainframes or multi-user systems. It allows multiple users to share same CPU time. Real-time OS. Real-time OS guarantees response times. They guarantees that processing within the strict time constraints. They are used in medical fields, mainly medical, industrial, and automotive systems. Then there is distributed OS. Yeah, distributed OS manages a network of computers to function like a single system. It manages a group of independent computers which act as a single system. Mobile OS, last but not least, mobile OS. Uh, it is mainly found in smartphones and tablets such as Android and iOS. Each type is optimized for its environment. Let's briefly go through the history of operating system and how they were involved. In 1950s, batch processing systems were introduced. In 1960s, the time sharing became very popular, letting multiple users use mainframe. 1970s brought Unix and personal computer revolution. The 1980s saw the rise of graphical user interface, the GUI, with Windows becoming mainstream. The 90s, the internet and Linux gained traction. The web browsing and open source movement. By the 2000s, the mobile computing and cloud-based systems began reshaping how we use computers. Let's now break down the key functions of an OS. The first one, memory management. It ensures program don't interfere with each other's memory space. The second, process management. It is responsible for executing programs and managing their life cycles. The third, file management. It organizes files and folders, handles the storage and retrieval. Input and output management coordinates the communication between the CPU and the peripheral devices. Last, security management. It protects data and resources from threats, unauthorized access, and system failures. Together, these functions make a computer usable, secure, and efficient. Okay, so this slide will give you a quick summary of OS types and their real world applications. The first one, batch OS, is often used in systems like payroll or billing. The time sharing OS works in multiple user environment like web servers. The real time OS is essential in places like hospitals and factories. The distributed OS supports cloud services or server farms. Last, mobile OS powers the smartphone and wearables, smartphone, tablet, and wearables, as you can see. It is a touch based interface. Let's look at some real world examples. For desktops, common OS includes Windows, Mac OS, Linux. On mobile devices, we use Android and iOS. In server world, Linux dominates alongside Windows Server and Unix based systems. Each OS is optimized for the for the hardware it runs on and the task it performs. To conclude, operating systems are absolutely vital for any computing device. They manage hardware resources, allow for multitasking, ensure security, and provides the interface we use every day. Understanding how they help us be- become better user. And for those of us studying computer science, it lays the groundwork for more advanced topics in software and system design. So let's end it here. Thank you for your time.